Hello, everyone. I am going to do my best and give you the notes through these videos. I'm going to try and make them short and sweet. A lot of the information that you're going to get from these slides, you don't need to know everything from them, but I'm going to cover them as best I can to give you enough information for your worksheets. Okay. Sometimes my slides might not catch up to my voice, or I'm going to try my best and do my best and see what works, because this computer that I've been working off of is not so great. I'm trying though. So, the atmosphere, you're breathing it right now. It's that thin envelope of gas that surrounds the Earth. It extends about 375 miles above sea level. And the elements in the atmosphere, that's going to be nitrogen and oxygen. You're actually breathing in a lot more nitrogen. You can see on this sheet, on this part of the reference table, this is on page 1. You'll see that you're breathing in about 70% by volume over oxygen. Oxygen's only 21%. And then we've got the other, which we're going to talk about in a little bit. Okay, so what did the atmosphere used to be like 2 billion years ago? When Earth was kind of still becoming itself, there wasn't any oxygen. It contained mostly water vapor and carbon dioxide. But after a while, once things started to evolve, there were plants, and the photosynthesis is what produced the oxygen and put that into the air. Okay. So the other things that are in the atmosphere that I was telling you about, besides oxygen and nitrogen, those others are water vapor, carbon dioxide, which you're breathing both of those out, methane, ozone, nitrous oxide, and CFCs. Okay. Chlorofluorocarbons, that's what CFCs are. Those used to be, and sometimes still are, in aerosol cans. They used to put those in those spray things that you spray around the room to make it smell better. CFCs are very tiny microscopic particles that stay floating around in the air forever. Once they get outside, they can get up into the atmosphere, and they actually are like little razors to the ozone, and they tear open the ozone. So they've tried to get rid of CFCs, but they've done their best. Now, here's the page in your reference tables. So I'm going to break this down for you. It looks a little confusing, but once you break it down, it's way easy, just like most charts in our reference table. Over here, you have your altitude. So this is how high up in the sky you are. Obviously, on the left, you have kilometers. On the right, you have miles. Okay, kilometers goes up by tens over here. Miles goes up by fives. All right. Now, in this center part, you have temperature. And as you can see, this solid black line represents the temperature at that certain altitude. So if I asked you, oh, what's the temperature at 80 kilometers? I'd come across until it hit that black line, and I'd follow it straight down. And for our case, it's this dotted line. It's negative 90 degrees Celsius right here. Okay. Now, if you notice, there's different spheres in this area, and that's because of different temperatures. So in the troposphere, as you go up in the atmosphere, the temperature is going down. Once you hit the tropopause, temperature changes, and it's going to start to go up in the stratosphere. And then as you go up in the mesosphere, it's going to go down again. And then when you get to the thermosphere, there's not enough atmosphere protecting you anymore. It's going to get hot because you're getting more rays from the sun. All right, so you have spheres. Where the temperature changes is where you have the pauses. Those are called interfaces. Next thing you have is pressure. As you go up in the atmosphere, pressure is going to decrease. Okay, so as you go up in the atmosphere, pressure decreases, things start to expand. That's why when you fly in an airplane, they have a pressurized chambers. It's because if you were up in the atmosphere that high, there's less pressure. It's not comfortable for you to be at. That's why your ears pop when you go up. And then for the last thing, there's a concentration of water vapor. If you notice, water vapor is only mostly in the troposphere. Very little of it goes up into the stratosphere. And as you go up in the atmosphere, there is no water vapor up here. Okay, water vapor is only going to be in the troposphere and very small amounts in the stratosphere. It's not even all the way up in the stratosphere. Okay, so again, altitude, how high up you are, temperature in the atmosphere. As you go up, pressure decreases. As you go up, water vapor decreases. Okay, now on this chart, it just basically tells you everything that we just talked about. You have this, so we're not going to spend a lot of time on it. Ozone. This is the unstable molecule that's composed of 3 atoms of oxygen. This helps block out those UV rays from the sun. It's about 15 miles above Earth's stratosphere. So if you look, it's about 15 miles up, so 5, 10, 15. Right about here in the stratosphere, this is where the ozone layer is. This protects us from UV rays. If we don't have the ozone, you're more likely to get direct rays from the sun, which is going to cause things like skin cancer. Okay. All weather takes place in the troposphere. Why? Because it's the only layer with water vapor. The interface, this is where I was telling you about where those pauses are. It's where the temperature is going to change. The isothermal layer, this is back here where the temperature stays the same for a little while. So they call this the isothermal layer. And going back, that's it. Okay, so make sure that you use your reference tables when you're going to do these worksheets. This chart will help you quite a bit.